back shortly. Just wait for a few minutes. I'll be back just shortly now. Okay guys, we are actually going to now continue with our session that we held yesterday for grade 9s. Okay, we had started answering some GEC questions, alright, and we had ended at question number 20. So we are going to continue now with number 21, okay? So hopefully we are all good to go. So let us just proceed forth and proceed forth in some pace that is notable. So if you look at number 21, that's where we are picking up, because we finished up number 20 yesterday, and hopefully those who made is number 20. Is it done? You are more than welcome to actually go to my YouTube channel. The link is in my bio. I have uploaded the video that I did of the live lesson yesterday. So today I'll continue on from there, and we'll be doing 21, 22, 23. We'll see where we end. Tend to get out of here by 5 to 7. Okay, let's go. The area of a rectangle is x squared minus x minus 2. So this question, guys, deserves a bit of our attention. We can't just proceed with number 21 and not note what is being stated. So this is grade 9 Sima. Grade 9. Is grade 9 is grade 9 in the mornings, okay? We are basically that the grade 9s are yet to write in the month of November. So we are doing a little bit at a time, and hopefully this with them. And then if you miss out, if you're school, you miss out on the information that is here, please do go to my YouTube channel. When you come back from school, make sure you go to the channel and you watch that lesson that you missed, so that you can actually also have the gaps closed. So number 21, that's where we are at. The area of a rectangle is x squared minus x minus 2. The area of the rectangle is what? X squared minus x minus 2. This is the area, guys, of the rectangle. Are we together? Now we know that a typical rectangle, guys, the area of a typical rectangle, we know that a rectangle has a length, which is what we call the horizontal dimension. Then it has a breadth, okay, which we can refer to as the vertical dimension. That's why we say a rectangle is two-dimensional, okay, because it has a horizontal dimension and a vertical dimension. When we talk about area, we are talking about basically calculating the space that is within a two-dimensional shape. If we want to cover the space within a two-dimensional shape, that's what we call its area. Okay, therefore, the area of a typical rectangle, if we want to calculate the space within, is actually length, the horizontal dimension, times breadth, the vertical dimension. This is the area of a rectangle. Now we are being told here that the area of a rectangle is x squared minus x minus 2, which means this area, guys, is in terms of x. The area that we have here is in terms of x. Its length, we don't know. Its breadth, we don't know, but we have the desire to calculate it. So we can therefore say that x squared minus x minus 2 is equal to this length times this breadth or this width. Remember, guys, breadth and width are the same thing. Width is simply the shortest side of a rectangle, and breadth is the same thing as your width. So what they are saying here is that we need to find what the length is And what is the width of this area of the rectangle, whose area is x squared minus x minus 2. So I'm sure, guys, you can see what is required of us here. We want to find the product of what? Of factors that make up x squared minus x minus 2. So that means we are going to apply factorization of what? We can see this is a trinomial. Because when we factorize this trinomial, we are surely going to get the independent dimensions of this rectangle, its length and its what? Its width, which are products. The products will give us the answer. The product of the factors, will give us this area, because area of a rectangle is equal to the length times the width. So if we want to get the independent length and the width of the area of this rectangle, we are going to apply factorization to the area. So this is the concept that is hidden in the question number 21. The area of a rectangle is x squared minus x minus 2. What is the length and width of the rectangle in terms of x? The question is saying find the length and the width in terms of x. So we are going to take x squared minus x minus 2, the area, and we are going to factorize it. Now, when we factorize, the first question we ask, is there a highest common factor here between x squared minus x and negative 2? So yes, there is a highest common factor, and the highest common factor is 1. That leaves us with x squared minus x minus 2. Secondly, this x squared minus x minus 2, what is this? It is a quadratic trinomial. Now, how do we factorize a quadratic trinomial? We open two brackets. Okay. Then what do? We find the factors of x squared. We know that it will be x and x, because x times x will give me the x squared. Then I need to find the factors of negative 2. This negative 2 here, guys, what do we know about it? We know that if there's a negative constant term, this means we are going to have different signs inside the bracket. Minus a constant term that is negative means that there's going to be different signs inside my bracket. Those different signs, the highest factor out of the factors of 2 will have a negative sign. All right. So the factors of 2, what are the factors of 2? We have 2 and 1. Okay, and those are the only factors of 2. So since we said negative 2 means we are going to have different signs inside my bracket, the highest factor out of the factors of 2 will have a negative sign. So between 2 and 1, the highest factor is 2. It will have a negative sign, and the other number or the other factor will have a positive sign. These are the different signs we are talking about. Multiplying negative 2 and positive 1 does give me negative 2. Good. Adding these two together, negative 2 plus 1 gives me the coefficient of x, which is negative 1. So these factors, they qualify, and the signs of the factors are 100% correct. So I'm going to come here and write minus 2 plus 1. So that means, guys, the product of the factors, okay, for my length and my width. My length in this case is going to be x plus 1. Okay. My width, because it's the longest side, my width is going to be x minus 2. And that's it. So if I go now back to my question, what is the length and width of the rectangle in terms of x? Okay, I've got a length of x plus 1, and I've got a width of x plus minus 2. Now you are going to ask yourself the question, why, sir, are you saying that the length is x plus 1 and you are saying the width is x minus 2? Remember, guys, the length must always be the longest side. And let's say, for instance, we knew what the value of x is. Let's say if x is 3, Then it's going to be 3 plus 1 here, which is going to give me 4. Then it's going to be 3 minus 2 here, which is going to give me 1. So this side is always going to be longer than this side, whatever value of x, which is the same that I substitute in the place of x. So I'm going to say my length is x plus 1 because this length times this breadth is going to give me the area, which is x squared minus x minus 2. So this is my answer. So if I go to number 21 and I check, A, is L going to be x plus 2 or W is equal to x plus 1? No. Is it B? No ways. B is not the answer. Is it C? No ways. Is it D? Yes. D goes hand in hand with the answer that I've gotten, and my working out is 100% correct. So I'm going to select the letter D as my answer. L is equal to what? X plus 1, and D is equal to what? X minus 2. So this is 100% correct, and this is how we would do number what? Number 21. Let's move on. We can now go do number 22. Number 22, we are given here 6x squared plus 18x minus 60 over 48x divided by x squared minus 4 over 8x. And number 22 says, what is the simplest form of the expression? Is it A, x plus 2 over x plus 5? Is it B, x minus 2 over x minus 5? Is it C, x plus 5 over x plus 2? Or is it D, x minus 5 over x minus 2? So we need to first go and write down the question. So the question here says 6x squared plus 18x minus 60 over 48x divided by x squared minus 4 over 8x. So we are going to now simplify this expression. All right. Now, in simplifying an expression in grade 9, we should have learned that if there's fractions and there's division and another fraction, what we need to do, step number 1, wherever we have division, okay, if there's a division sign, we need to change that to multiply. So division always changes to multiply, and when that happens, the fraction which follows is written the fraction which follows is inverted. Okay, it's inverted. So if we change divide to multiply, the fraction which follows the division sign will be inverted. By inverted, guys, it means that the numerator becomes the denominator and the denominator becomes the numerator. So let's rewrite this question as our first step. Whenever there is a division sign, we change division to multiplication. Then the denominator becomes the numerator becomes the denominator. So it's 8x over x squared minus 4. That's step number 1. You get a mark for changing division to multiplication, and then it's always fraction number, then the fraction that follows the division sign that flips. Okay, it flips over. It inverts. So 8x now is in the numerator and x squared minus 4 is in the denominator. That's step 1. If there's a division sign, we change it to multiply. Step 2, factorize the numerator or denominator of each fraction if possible. what do? We factorize the what? The numerator or the denominator, if what? Of each factor, of each fraction, if possible. So let's come back here. Let's look at the numerator. Can we factorize the numerator, guys? And if we can, what sort of factorization should we always think about whenever we factorize? What's the first form of factorization we need to always think about when factorizing? The first form, guys, of factorization that we must utilize is we must use the highest common factor. Take out the highest common factor if possible. Right? Then obviously there's other types of factorization, trinomial quadratic factorization. Okay, then there's also difference of two squares factorization. There's also common bracket, taking out the common bracket factorization. There's also grouping factorization. So we have these varying types of factorization methods that need to be well known by us. So if we come here, we can clearly see that 6x squared plus 18x minus 60, there is a what that we can take out here, a highest common factor. So if we look at the first term, we have 6. Second term, we have 18. Negative 60 is our last term. So there's a common factor. There's something that is common between these 1, 2, 3 terms. And what is that? The common factor between 6x squared, 18x, and negative 60 is what? It is 6. So we can see that. Okay? So we take out positive 6 as the highest common factor. Then between our variable x squared x, x is not common, so we don't take out x. Then we open a bracket. What is left inside after taking out 6? 6 times what gives us x squared? Or in other words, what is 6 divided by 6? What are we left with? We are left with 1. And then the x squared that was there is also left behind inside the bracket as our first term. We go to our second term. 6 times what gives us 18x? Or in other words, what's 18 divided by 6? 6 times what gives us 18? It's 6 times, if it's positive, positive times what gives us a positive? It is positive. 6 times what gives you 18? 6 times what gives you 18? Or what is 18 divided by 6? So that gives us 3. And then the x that was there, there's no x that is outside, so we need to write that x. 6 times what gives you negative 60? Positive times what gives you a negative? It's negative. And then 6 times what gives you 60? Or you can say, what is 60 divided by 6? It is 10. So that is how we factorize that numerator. We have over 48x. We are going to leave that for now. Times 8x over. Now, here, can we factorize this? Definitely we can. Factorizing x squared minus 4. What type of factorization is that? X squared is a perfect square. 4 is a perfect square. Negative is a difference. So that means we have a difference of 2 squares. So what do we do when we are factorizing difference of 2 squares? If the coefficient of x squared is positive 1, then we can immediately open 2 brackets. Okay? And when we open those 2 brackets, we then ask ourselves the square root of x squared. What is the square root of x squared? It is x, guys. So that means in our first bracket, we are going to write x and x, because x times x will give me x squared. There's a 4 there. There's a difference of 2 squares. So I can now say, what is the square root of 4? The square root of 4 is 2. So that means I'm going to write 2. Then here, guys, since there's a negative sign for my constant term, that says to you we are going to have different signs inside the bracket. One positive, the other one negative. And that is my x squared minus 4 factorized. Okay. Now I'm not quite done. Okay. With this numerator, I can still factorize further. because I'm sure you can see that x squared plus 3x minus 10 is a trinomial, 3 terms, and it's quadratic trinomial that we have. So we can factorize x squared plus 3x minus 10. How? We have a negative 10. That means we are going to have different signs inside my bracket. We have a positive 3, which means the factors of 10 that I choose means that the highest factor is going to have a positive sign. So let's go and list the factors of 10. We have 10 and 1. We have 5 and 2. Those are the only factors of 10 that we have. Then, according to the sign of the middle term, since it is positive, if my signs are going to be different, because remember, when a constant term is negative, it means that my signs inside the bracket are going to be different. But this positive sign says to me, the highest factor is going to be positive. So that means highest is 10 here. Highest is 5 here. They are going to be positive. Then the other signs, negative, negative. Now, let us check. When I multiply, I'm sorry guys for the blurriness. I don't know what happens here sometimes. It becomes blurry, this thing. For what? I have no cooking clue. Okay, and it actually irritates me as someone who is teaching. So if we multiply 10 and negative 1, we do get negative 10. If we multiply 5 and negative 2, we get negative 10. But in order to get this middle coefficient, which is positive 3, we need to add, what's 10 minus 1? This gives us 9. It's not working. What's 5 minus 2? This gives us 3. So when we add these two, we do get the coefficient of the middle term. So which one works? Plus 5 minus 2. Then we have x and x. This is how we factorize x squared plus 3x minus 10 over 48x times 8x over x plus 2 into x minus 2. Now, we are going to play the cancellation game. Step number 3. After factorizing completely, we can play the cancellation game. The cancellation game, maths gamers, applies when you have common brackets at the top and the bottom. And also it will apply for numbers or variables that are common or have a highest common factor amongst themselves. So let's start here at the top and check what has factors that we can cancel. So if you look at 6 and 48, 6 and 48 do have a highest common factor, which is what? It is 6. So I'm going to say, how many times does 6 go into 6? Goes there once. How many times does 6 go into 48? It goes there 8 times. Are we together? Because I am dividing 6 with 48. 6 and 48 have a highest common factor of 6. How many times does 6 go into 6? Once. How many times does 6 go into 48? 8 times. All right? Then let's move on. Let's go to x plus 5. X plus 5. If I look at the bottom, there's no x plus 5. But x plus 5, if I look at the bottom of the other fraction, do I have an x plus 5 here? No, I don't. So that means x plus 5 is going to stay there as the champion of the numerator. It's not going on anywhere. Let's go to x minus 2. If we look at x minus 2 here, we look down here, there's no x minus 2. So it means there's nothing that we can cancel here. We move on to the second fraction because we are multiplying. X minus 2 does have a common bracket of x minus 2 in the denominator here. So that means cancellation can happen because x minus 2 goes into x minus 2 once, just like x minus 2 and x minus 2 goes into x minus 2 once. So that when we cancel, guys, 1 gets left behind in the numerator and the denominator of those expressions. Let's move on to this fraction. We have 8x here, all right? And at the bottom here, we had x. So this x, which is multiplied, and this x that is multiplied to the 8, they cancel. We write 1 and 1. Also remember this 8. Remember this 8. This 8 and that 8 that was left over. This 8 gets cancelled and this 8 gets cancelled. We get left with 1 and 1. Alright? So guys, there's nothing else to factor or to cancel or simplify. So now I'm going to write everything that is left over from the top and the bottom. Now I can simply do this, and it's very nice to do. 1 times x plus 5 in brackets times 1 times 1 times 1. What does that give me in the numerator? In the numerator, it gives me x plus 5. Okay? Alright? Morning, Mushi. Then in the denominator, what is left over? 1 times the 1 that's left over times the x plus 2 times the 1. That leaves me with what in the denominator? X plus 2. That's what's left over. That's how we simplify this. So the cancellation game helps us to be able to get the simplified version of this expression. Guys, what did I do to get here? As I said to you, we first look at the fractions divided. Then we first look at, if there's a division sign, we change divide to multiply. And what happens to the fraction that follows the division sign? It inverts. In other words, it flips around. The denominator becomes the numerator becomes the denominator. So we have 8x over x squared minus 4, my beloved grade 9s. After that, we factorize. We do what? We then, after changing the sign and flipping the fraction, step number 2, we factorize, if possible, the numerator and the denominator. We saw that here in the numerator, we can factorize. We can take out the highest common factor first. Here in the denominator, we leave 48x. Here in this numerator, we leave 8x. Here in this denominator, we can factorize x squared minus 4, because this is what we call factorization called difference of two squares, because x squared is a perfect square, 4 is a perfect square, minus is the difference. So a difference of two squares can be factorized by taking the square root of the first term, which is x in this case, so we write x and x, taking the square root of the second term, which is square root of 4 is 2, we write 2 and 2, and then because the constant term is negative, that means we are going to have different signs inside the bracket. That's why we have plus and minus. Then after taking out the highest common factor here, we can further factorize this, because this is a quadratic trinomial. We open two brackets, x squared, x and x. The factors of 10, we have 10 and 1, 5 and 2. Because this negative sign of the constant is negative, we know that means we are going to have different signs for our factors. But the highest factor, according to the middle term, the highest factor should have what sign? A positive sign. Hence the 10 is positive, hence the 5 is positive. For these factors, the highest number should be positive and the other numbers should be negative. Then we check which one is going to work when we add. 10 minus 1 doesn't give me 3, so it's not going to work. 5 minus 2 does give me positive 3. It works. So that means in my bracket, I'm going to have 5 that is positive. I'm going to have 2 that is negative. And then that's how I factorize. After that, step 3, play cancellation game. And cancellation game only applies for top cancel bottom. We don't say top cancel top. No, we say top cancel bottom. Top cancels bottom or bottom cancels top. Please, guys. All right. So that is why here after simplification, I get x plus 5 over x plus 2. I go to my question paper. I go to the options. What is the simplest form of the expression? Is it A, x plus 2 over x plus 5? No. B, x minus 2 over x minus 5? No. C, x plus 5 over x plus 2. Yes, it aligns with the accurate simplification that I did. I got x plus 5 over x plus 2. This is my answer. So my option that I should then choose, GEC learner, is C. All right. So I'm trying to really sensitize you grade 9s that as you answer GEC questions, you have to do calculations on the side, then select the correct option, and you must make sure that your maths is mathsing. Your maths must be top notch, top level Shayela maths. It must not be maths that is uninformed. So practice, practice, practice. As you guys join my live lessons in the mornings, you will be able to get the motivation, the encouragement to actually do the work that needs to be done. Please, guys, you need to work on it. If you want to do maths in grade 10 next year as a grade 9 learner, you need to work on your maths so that the marks can reflect. Okay. All right, let's move on to the next question. Okay, there we are. Number 23. Number 23. 15s to the power 4 minus 15z to the power 4. What are the factors? Are you able to post the question paper? I'll do that for you guys. I'll post the question paper. It's just that every morning I'm doing these question papers, and then after that the video I save and then I upload it onto the YouTube channel. All right, so what I'll do is I'll screenshot the questions for this paper that I'm doing ahead of time, and then I'll post it as a video slideshow onto the TikTok page so that you guys can actually you can download the pictures and then you can actually do them as you want. Or you could just go to Google and check it out and type in the GEC. This is a 2022 paper, the GEC 2022 paper 1. Okay, because every morning I'm going to be doing the respective papers. I'm just starting with 2022 for the next few mornings. In the next few mornings I'll do 2023. Next few mornings I'll do 2024. By the time you guys write, you will have at least gotten a solid picture of how to approach these questions and how to do them. So if you missed the lessons, guys, please go to my YouTube channel, go and watch the lesson if you have missed it, because I post the lessons after I'm done. I see you there, Shlomile Willie. So try saying. All right, 23. What are the factors if the expression is factorized fully? So we have 15s to the power 4 minus 15z to the power 4. We're supposed to factorize the expression fully. Please, guys, factorizing an expression fully requires some good skill. Okay. Now, when you look at this question at first glance, remember when we factorize, the first thing we always check, is there a highest common factor? Whenever you factorize, guys, you always ask, is there a highest common factor? A highest common factor sign, a highest common factor number, and a highest common factor letter or variable. Sign, number, letter. If the first term is negative, you take out the sign of the first term. If the first term is positive, you take out the sign of the first term. So between 15s to the power 4 minus 15z to the power 4, the sign of the first term is positive. So that means we are going to take out a positive sign as a highest common factor. Then we go on to the number. Between 15 and 15, what is the highest common factor? Obviously, it is 15. Letter S and Z, is it common? No. So there's no highest common factor. What? Letter. There isn't a highest common factor letter. So if we take out a common factor, we are going to take out 15, guys. All right. Then we open the brackets. What's left behind? As our first term, if we take out 15, what's left behind is S to the power 4 minus, what's left behind on the right side is Z to the power 4. Are we together? I hope we're together, guys. All right, that's the first step. After taking out the highest common factor, we then check, do we have trinomial factorization following up? Or do we have dots factorization, meaning a difference of two squares? Or do we have grouping or any other type of factorization? So if you look here, you can see this is a what? Very good, this is a difference minus of what? Of two perfect squares. How do we know, guys, that these are perfect squares? S to the power 4. It's because any variable, a variable with an even exponent. What do we mean by even? Guys, even numbers are numbers that are divisible by 2, right? So 4 can be divided by 2 and it leaves no remainder. 4 as an exponent is an even number. These are even exponents. So variables with an even exponent are perfect square variables. These are perfect square variables. Let's never forget that. Any variable with an even exponent is what we call a perfect square. So that's why we say this is a difference of what? This is a perfect square s to the power 4 because it's a variable with an even exponent. This is a perfect square z to the power 4 because it's a perfect square with an even exponent. So then when we proceed, we are going to open what? 2 brackets. And guys, immediately I can place my signs positive, negative. I prefer to start with a positive sign and end with a negative sign when I'm doing a difference of what? Of 2 squares, always, guys. Then you can say, what is the square root of s to the power 4? Remember, the square root of s to the power 4 is the same thing as saying s to the power 4 divided by 2. When you remove the square root, that gives you s to the power 2. So that means I can write s to the power 2 here and s to the power 2 there. Are we together? Hey, I hope we are flowing, guys. I hope we are understanding this thing. I hope some of you are like, wow, okay, this is eye-opening. I didn't really get it when I was doing it in term what, but now it's making so much sense. It is senseful, not senseless. Okay, then z to the power 4. I say, what is the square root of z to the power 4? Z to the power 4 is z to the power 4 divided by 2, which is actually z what? Z squared. So that means I'm going to write z squared and z squared. Okay, guys, this is s and this is z. Okay, now if I relook at the expression, it seems like there's more to be done. Why? Because if you look at your first bracket, okay, you cannot factorize this any further because this is a sum of 2 squares. Guys, a sum of 2 squares is unfactorizable. A sum of 2 squares, we cannot factorize that. Okay, we cannot factorize a sum of 2 squares, but you can factorize a difference of 2 squares. Laurie at Gabs, you've been actually making comments that are actually disruptive and actually just sidetracking. Okay, one of 2 things. You can stay in the live and just gift me rather instead than post these things that are distracting and are destructive and are not building. You need to ask yourself the question, this morning as you are doing what you are doing, is it helping the situation or is it just not assisting in the situation? Because remember, there's learners that are here and that are genuinely learning. You are here to basically do what you are doing, and I don't know why you are doing it, but you need to reflect on your actions. Okay, so please take some serious reflection time and reflect on your actions. Are your actions helping the situation, or you are just okay, so s squared, thank you very much. You see now you are helping the situation instead of posting Pythagoras and probability, 15 into s squared plus z squared can't factorize, but we can see here we have another difference of what? Of 2 squares, like Ini said. Okay, we said there's a difference of 2 squares in the other bracket. So that means we open 2 additional brackets and we can factorize this. So we are focusing on this bracket and we are opening two brackets for it. Guys, that's why I personally start with the positive sign and follow it with the negative sign. That allows me, in the situation that this is still factorizable further, then I can have the space of opening two brackets at the end, not at the front, but at the end. Opening two brackets and then factorizing in the situation or the case where this is still factorizable, because it is a difference of two squares. Thank you, Vinny. Thank you, Lori. I think now we are talking, my lead. Plus minus for a difference of two squares. Then what is the square root of s squared? That's like saying s square root of s squared is s to the power 2 over 2. That gives us s to the power 1. So that is s. We write s and s there. What is the square root of z squared? That's like saying z to the power 2 over 2, which is z. So we can write there z and z. Or as the Americans say, z and z. All right? Okay, thank you so much, guys. Vinny, appreciate it. So there it is, guys. Can we factorize any further? No. Factorization is complete. All right, then we go to our options. Which option here is the right one? What are the factors if the expression is factorized fully? Is it A? No, you can see it's not A, guys. A is partly factorized, it's not fully factorized. B, no. S minus Z is there. S plus Z is there. S squared plus Z squared is there. So that means this is applicable. But if you look at D, D is out. So that means 23. We go for C. And that has been actually worked out, and we can see that that is actually the answer. Okay? Guys, hey, I hope we are together here so nicely. So nicely we flow. So nicely we flow. Factorization is a cinch. Factorization is a cinch. There's nothing to it. Let's move on to number 24. Okay. Number 24, we are given an equation there. X minus 5 is equal to negative 7. This one is a giveaway. What is the value of x? So when we enter into this question, what are we dealing with here? We are dealing with solving for x, or solving for an unknown variable. So let's go and check it out. X minus 5 is equal to what? Is equal to negative 7. So we should know what we should do here, most. Not a problem. I believe that there is this TikTok teacher influencer called Sekolo. Sekolo's grade 2 learners can solve for x. Learners that are in what? That are in grade 2. So it would be a big shame if a learner in grade 9 and 8 cannot solve for x, whereas Sekolo's grade 2 learners can solve for x. Okay, so let us solve this. X minus 5 is equal to negative 7. We know what we do is we look at how many terms are in the expression on the left. We have 1, 2 terms, because terms are separated by a plus and a minus sign. We want to isolate x, make x be alone. So that means we take negative 5 as a second term, we transpose it. When we transpose, or when negative 5 crosses over the equal sign, what happens to negative 5? He changes the sign. All right. And then what do we then do? Negative 7 plus 5. What's negative 7 plus 5? It is equal to negative 2. So then if we go to our options, guys, what is the value of x? Is it A, 2? B, is it 12? C, is it negative 2? D, is it negative 14? I'm sure, guys, we can clearly see that our x value here can none other be what? X has to be what, guys? Negative 2. So that is what? From the option for our multiple choice, it is C. Okay, so 24 is definitely going to be C. Okay, moving right along. 25. 3x plus 1 over 2 is equal to 5. What is the value of what? Of x. Now with a question like this, guys, very nice, very sweet, not a problem to do. We have 3x plus 1. It is divided by 2. So what we want is to isolate x, but there are few things standing in the way of x for it to be isolated. You see here it was easy. We isolated x simply by taking -5 because there are two terms in the expression on the left, so the -5 can be transposed. Changes sign, we get the answer. That was straightforward. But this one, we have 3x plus 1, it's divided by 2. So we can't take 1, for instance, and just transpose it. Why? Because this fraction, all of it is one term. You can't take plus 1 and just transpose it. No, no, no. But as Mushi said in the comment section, we have to first multiply to cancel the 2 that is divided by 3x plus 1. So what we can do, guys, is we can do the following. We multiply in the numerator by 2. When we do that on the left, what we do on the left, we have to do where? On the right. So if we multiply by 2, why are we doing that? It's because 2 in the numerator and 2 in the denominator will cancel each other. 2 divided by 2 will give us 1, thus eliminating the denominator, which is 2. So we have 1 in the numerator, we have 1 in the denominator. That leaves us with 1 into 3x plus 1, which is equal to 10. Remember that 1 in the denominator, guys, does not really hold any significance. So that 1 that is there, even if we did not write it down, we know it is there. Okay, then we take the 1, we distribute it inside the bracket. That removes the bracket. We get 3x plus 1 is equal to 10. Now we have two terms on the left hand side. Plus 1 needs to be transposed to its like term. So that helps us isolate 3x. We transpose positive 1, it becomes -1 on the other side. We now have 3x is equal to what's 10 minus 1? It is 9. Then we want x. So what do we do now? We divide both sides by 3. Okay. How did we get 10? Initially, 3x plus 1 was divided by 2, which is equal to 5. We want to solve for the value of x. X is actually in the midst of plus 1 divided by 2. This is one term. A fraction is always one term. We want to solve for x. Isolate or have x alone on the left hand side. So the first thing we do is we multiply both sides. We use the inverse operation. Since 3x plus 1 is divided by 2, we multiply in the numerator by the 2. Okay, but what we do on the left in equations, we have to do where? On the right. So if we multiply by 2 in the numerator on the left, we have to multiply by 2 on the right. So 2 times divided by this 2 means 2 and 2 cancel. 2 goes into 2 once, 2 goes into 2 once. Yes, I love that, Mushi. Your teacher saying it's like making x feel lonely. Yes, it's like you as a learner, for instance, you need to be lonely in your high school, hopefully. You keep the girlfriends away for now so that you can actually do justice and get your highest marks without having other emotional entanglements and commitments that will hold you down. So yes, X is like you need to be lonely, aspiring for academic excellence, making sure there's no distractions. So you multiply by 2 here on the left. What you do on the left, you do on the right. So the 5 times 2, that's how I got 10. Okay, that's how 10 arrived. Then the 2 and the 2, they cancel. I'm left with 1 times the 3x plus 1. When I distribute the 1, I get 3x plus 1. 1 times 3x is 3x, 1 times 1 is 1. The 3x plus 1 is equal to 10. I then take the 1, I transpose it. 10 minus 1 gives me 9. then when I'm here, guys, the 3 and the x have a relationship of multiplication. 3 and x are multiplied to each other. How do I get rid of something that's multiplied to x? I use the opposite operation. I divide by 3. But remember, what I do on the left, I need to do where? On the right. So then I'm left with what? What's 3 divided by 3? That leaves me with x. 9 divided by 3 gives me 3. So my answer is equal to 3. Okay. So hopefully that answers that question of the young man that was asking, where did the 10 come from? That's where the 10 came from. So now, if we go to our answers, what is the value of x? Is it A, -4, B, +4, C, -3, or D, 3? Obviously, guys, 25 is going to be D because our answer is +3. The answer is going to be D because the answer is +3. The answer that we select is D because the answer is +3. I don't know if you're seeing the rhyme, guys. 3 and D. 3 is D. All right. Okay. Hopefully you guys got that. But anyways, whatever, guys. Let's move on. Next beautiful question before I now leave. This is the last for today, guys. Unfortunately, I know you guys are so enthralled. So x into x minus 4, number 26. What is the solution of the equation? What is the solution of the equation? Is it A, x is equal to -4 or x is equal to 0? B, x is equal to 0, x is equal to 4? C, x is equal to 0 alone? Or D, x is equal to -4 alone? So what is the solution of the equation x into x minus 4? Guys, remember, here we have a product of factors. In other words, we have x into x minus 4 and we have a 0 on the right hand side. So if we have a product of factors and there's a 0 on the other side, we can apply the 0 factor law. So that means we are going to say x, we take this factor, equate it to 0, guys. But this only applies if there's a product, meaning a multiplication of two factors equated to 0. We call this the 0 factor law. So I can say x is equal to 0 or x minus 4 is equal to 0. Then from there, you can see this is my first answer. But look at this one. I can solve this one. X minus 4 is 2 terms. Let's make x feel lonely, like Mushi said. We take -4, we transpose it. X is equal to +4. So these are my two answers. X is equal to 0 or x is equal to 4. Those are my two answers. So if I go to my options, what is the solution of the equation? Is it A? Is it B? Is it C? Is it D? I'm sure you guys can see that the answer is going to be what? B. It can't be A, it can't be C, it can't be D. It is B. Right, guys. That's all for today. Thank you so much for joining in. I hope you guys have a wonderful, amazing, what is it, Tuesday? Is it a Tuesday today? Yeah. And please, guys, make it a point. Last question, please. I'm sure I have to go. Okay, let's do last question. Since Moshe asked so kindly, let's do a last one. 27. 6 to the power x minus 1 is equal to 36. So let's look at this one, guys. This one is an exponential equation. What is it? Exponential what equation? 6 to the power x minus 1 is equal to 36. Okay, so for exponential equations, we know that there's a property that says if a to the power x is equal to a to the power y, then we know we can say x is equal to y. So what's important here is that the bases on either side of the exponential equation need to be the same so that you can drop these bases and equate the exponent. Okay, so let's come here. 6 to the power x minus 1. The base here is 6. 36 can be written as 6 squared. How do I know that? It's because I know my maths. 36 can be written as 6 squared. Why did I basically write 36 as 6 squared? It's because this 6 that I see here is a guiding number base that says to me, please somehow get this 36 to have the same base so that we can apply this property. So since I now have base 6 on the left and base 6 on the right, I can now drop the base and equate the exponents. So I'm going to say x minus 1 is equal to this 2 because the bases are the same. And then I can solve for x here. So x is equal to 2 plus 1, which means x is equal to 3. Finished. Done. Dusted. So you can see that there's our options. What is the value of x? Is it 2? A? Is it 3? B? Is it C? -1? Or is it D? -3? You guys can see that the answer there is 27 what? It's 27B. Guys, I'm out of here. Thank you so much. It was great. Hope you have a great day. Thank you so much for those that gifted. Thank you for the roses. I really appreciate it. It means a lot. I know it means a lot, but have a great day. I'll see you again, same time, same place, tomorrow morning. I'll be posting this video onto my YouTube channel. Please, guys, the link is in the bio for the YouTube channel. Please subscribe, like, comment, do all sorts of things on those videos and all of that stuff. And those who may have missed the lesson from the beginning, you have that opportunity to check it out there. I've done, for instance, question 1 to 10. The live video is on the YouTube channel. Question 10 to 20, the videos are on the channel. And then now I've just done 20 to 27. So tomorrow I'll be picking it up, 28, moving forward, and we will complete 2022, move on to 2023, move on to 2024. Preparation for our exams. Great, nice. Thank you so much. Have a great day.